Hi, my name is Siti Nurmaizatul Akmal binti Cik Hussein. My metric number is 2023834988.
Hi, my name is Nurmal Kisnadira binti Ahmad Zulkarnain. My ID student is 2023852896.
My name is Fatih Shazanani binti Ismail. My student ID is 2023464354.
My name is Nur Ba'i Maisarah binti Marzian and my metric number is 2023895222.
The objective of the experiments are to record the frequency of each flavor, to calculate the experimental and theoretical probabilities for each flavor, to identify the differences between experimental and theoretical probabilities, to present a discrete probability distributions for the data, to calculate the expected value mean for the probability distributions. We have 3 different flavors of sweets, which is mango, tamarind, and coffee. We have 9 sweets of mango flavors, 13 sweets of tamarind flavor, and 8 sweets of coffee flavor. So the total sweets is 30. First, we need 3 flavors of sweets with different amounts, and put all of them in the box. Shake the box so that all the sweet flavors are mixed. Make sure to close your eyes before picking a sweet. Student 1 has to pick one of the sweets in the box randomly. Meanwhile, Student 2 has to record what type of flavor Student 1 picks up and put it back in the box. Repeat the procedures until it reaches 30 trials. The results shows that the frequency for mango flavor is 9/30. For tamarind flavor, 17/30, and the last one for coffee flavor is 4/30.
Let's dive into findings for question A, which focus on the frequency of each flavor across all sweets. We have 3 different flavors, which is mango, tamarind, and coffee, and the data is summarized in table 3.1. For mango, the total frequency recorded was 9. As seen from the tally marks in the table, we can see that it unchanged to its total flavor. Moving to tamarind, it was the most frequent flavor, appearing 70 times from the total flavors was 30. Lastly, coffee had the least frequency, showing up only 4 times, for its total flavor was 8. Now, let's move to question B, which involves calculating the experimental probability of obtaining each flavor, mango, tamarind, and coffee. As shown in the formula on the slide, experimental probability is determined by dividing the number of times an event occurs by the total number of trials. In this case, for mango, the probability is calculated as 9/30, representing 9 occurrences out of 30 trials. For tamarind, which the most frequent flavor, the probability is 70/30. Lastly, coffee, the least frequent flavor, has a probability of 4/30. These probabilities provide a clearer understanding of how often each flavor is likely to occur in a random selection. Tamarind has the highest likelihood, while coffee is the least experimental probability.
For question C, what is the theoretical probability of obtaining each of the flavors, which is mango, tamarind, and coffee? To calculate the theoretical probability, we can use its formula, which is number of desired outcome divide total number of possible outcome. So, Theoretical probability of mango sweet is 9/30. Theoretical probability of tamarind sweet is 10/30, while the theoretical probability of coffee sweet is 8/30. For question D, what is the difference between experimental probability of obtaining mango flavors and the theoretical probability of obtaining mango flavors? The experimental probability is equal to 9/30, while the theoretical probability is 9/30. 9/30 minus 9/30 is equal to 0. Then we multiply it with 100% because the question asks to come up with percentage. So the final answer is 0%.
For question E, what is the difference between experimental probability of obtaining tamarind flavor and the theoretical probability of obtaining tamarind flavor? Write the answer as the percent rounded to the nearest whole percentage. So, to find the difference, we need to use this formula, which is experimental probability minus theoretical probability, and we will multiply with 100%. So, for tamarind flavor, we got 17/30 minus 13/30 and multiply with 100%. So, the answer is 13%. So, for question F, what is the difference between experimental probability of obtaining coffee's flavor and the theoretical probability of obtaining coffee's flavor? Write the answer as a percent rounded to the nearest whole percentage. So, to find the difference, we can use the formula from the previous question, question E. The formula is experimental probability minus theoretical probability and multiply it with 100%. So, for coffee's flavor, we got 4/30 minus 8/30 and multiply with 100%. So, the answer we got is negative 13%. For question G, what is the experimental probability the selected sweets are not mango? So, for this question, we need to use this formula, which is experimental probability of tamarind flavor plus experimental probability of coffee's flavor. So, we got 17/30 plus 4/30 and the answer is 7/10.
Let's move on to the question for this experiment. The length of time required to develop a resource website denoted by random variable W in hours has a probability density function given as follows. For the first question, it's asked to determine the value of Y. To solve this, we will use the probability density function formula, which is integrate minus infinity to infinity fw dw equal to 1. To solve this question, we start with integrate 0 to 3 3/y multiply 3y minus y square dw equal to 1. Then we expand and integrate, substitute the lower and upper bound value in the function and compute the definite integral. After we rearrange the equation to isolate y, we will get 26/9 for the value of y. Next, for question B, the question asks to find the probability that it will take more than 30 minutes for the resource website to be developed. For solution, again, we use the probability density function formula as the first question. We substitute the value of y, which is 26/9, into fw, where fw is 3/y multiply 3y minus y square. Then the answer will be 1/3. Next, due to variable w is in hour, we have to write 0.5 instead of 30 minutes. So, integrate 0.5 to 3, 1/3 dw. So, it will be 5/6 for the last answer. For the last question, given that the discrete random variable b equal to w plus 2/4, so let's determine the value of EB. Firstly, to calculate EW, integrate 0 to 3W times FW dW. Then we substitute the value of FW, which is 1/3, into the integration. So we got the answer 9/6. Next step, substitute the discrete random variable given into EB. Then after we expand it, it will be 1/4 EW plus 2/4. Finally, we substitute the value of EW, which is 9/6, into the equation, and we got 0.875 for the very final answer.
For the conclusion, the experiment aimed to find the probability of selecting each type of sweet randomly. Sweets were picked with replacement, keeping the total number unchanged, and the picker closed their eyes to ensure fairness. Results were recorded carefully using a table and tally sheet to avoid mistakes. Challenges included recording errors, poor lighting, and distractions which could affect randomness and accuracy. To address this, the experiment was done in a quiet and bright space. Overall, the experiment demonstrated the expected trends in probability and show how probability works in a real-life scenarios such as predicting outcomes or making decisions in uncertain situations. Additionally, the experiment highlights the importance of randomness in ensuring that each type of sweet has an equal and fair chance of being chosen.